Continuing on with 13.1, please make sure to have a calculator. When we start getting into utilizing some of our formulas to solving for side length in a right triangle, you can use the following methods. Pythagorean theorem is pretty common, a squared plus b squared equals c squared, and then SOHCAHTOA. But notice how I wrote out SOHCAHTOA. It's kind of a nice way to remember the fraction rule that applies to the trig definition. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. When we round side length, we're going to go to the nearest tenth. So let's look at the first example. Find or solve for the side length b if capital C is 90, a is 32, and little c is 17. If we know that we have a 90-degree angle, let's go ahead and just create a right triangle. And I know that angle C is 90 degrees, so I'm going to put C down there with that 90-degree mark, and A and B can go in either other location. Angle A is 32, and well, that's a 2 right there. And then C, which is opposite capital C, is 17. And we're asked to find little b, the side length opposite side b. That would be that side length right there. Thinking about Pythagorean theorem and SOHCAHTOA, we could do Pythagorean theorem if we knew 2 of the 3 sides, but we only know 1 side. This means SOHCAHTOA is going to be our option. If angle 32 is given, then side B is the adjacent side, and 17 is the hypotenuse. So thinking SOHCAHTOA, the 2 side lengths that relate adjacent and hypotenuse have the cosine ratio. Therefore, we'll start with cosine A equals adjacent over hypotenuse, that A over H ratio. That's a P, there we go, HYP. Angle A is 32, that means cosine 32 will go on the left-hand side. On the right-hand side, the adjacent side length is B, that's the side we're solving for, and the hypotenuse is 17. To get B by itself, let's go ahead and multiply each side by 17. And then your goal is to isolate your variable first and then plug in everything at once on your calculator. Notice B is by itself on that right-hand side. That means we can take 17 times cosine 32 all at once on the right-hand side. Go ahead and type that in and make sure that you get an answer that's approximately 14.4 to the nearest tenth. In a given triangle, when you're asked to solve for a specific angle measure, you can use a couple of different methods again. The triangle sum rule simply means in any triangle, the 3 angles on the inside must have a sum of 180 degrees. But we can also use something different called SOHCAHTOA inverse. On your calculator where you see SIN, COS, and TAN, right above it you should see SIN -1, COS -1, and TAN -1. Those are the inverse functions for sine, cosine, and tangent. And again, we'll round our answers to the nearest tenth. Solve for the measure of angle A if C is 90, little a is 3.5, and little b is 5.2. Let's go ahead and create a right triangle to model this picture. Notice angle C is 90 again, so I'm going to put C down here. Angle A and B can be represented on either side length. Now it says the length of little a is 3.5. That's directly across angle A, that would be at the bottom. And side B is directly across angle B, that's over on the left-hand side for my picture, 5.2. And we're asked to find the measure of angle A. That means we're trying to find this value in the corner. How big is that angle? Again, thinking SOHCAHTOA and inverse, this time the 3.5 and the 5.2 represent opposite and adjacent. And looking at our SOHCAHTOA inverse, that's going to be tangent. So we'll say tangent of A equals opposite divided by adjacent. When we plug in what we know this time, we don't know capital A, therefore we'll leave it on that left-hand side. On the right-hand side, opposite is 3.5 and adjacent is 5.2. Now, here's the tricky part. When we take the inverse, what happens on the left is A is by itself. Notice I'm not dividing by the TAN. It's not TAN times A. It's just tangent angle A. To get A by itself, I move tangent to the right-hand side by doing that inverse function. And then we put 3.5 over 5.2 in parentheses. So you'll have to hit like your shift or second function key to get tan -1 to show up. That's the button right above tangent. And then type 3.5 divided by 5.2 into your calculator and press enter. Our answer is an angle, so this is a capital A answer. Please make sure that you get approximately 33.9, and our label is a degree symbol. That would be the measure of angle A. The two examples up above, we just found one part that was missing in each right triangle. When you're asked to actually solve a right triangle, what that indicates is you're finding all missing sides and angles, not just one particular side or angle. Here's what I mean. Example A for A and B, solve each triangle. So now I have different letters. We'll just see what this looks like. Triangle DEF with right angle E. First thing you want to do is draw your right triangle and always identify where your right angle is, and that's capital E. D and F, you can write them in either order. I'm just going to put them like so. Triangle DEF. Now, little e is directly across capital E, and that's 20. Little f is across angle F or capital F, and that's going to be on that left-hand side. That's 6. So notice we have two sides in this right triangle and the right angle. The first thing you'd want to do here is find the length of lowercase d. That's the side length directly across angle D. And we'll do Pythagorean theorem. Anytime you know two sides, Pythagorean theorem can give you that missing side. So I'm going to do d squared plus 6 squared equals 20 squared. Go ahead and pause the video and see if you can get d by itself. Round your final answer to the nearest tenth. Then press play and we'll continue. I ended up with d equaling approximately 19.1. Now, if you get an approximated answer, your goal is to try not to using that one to find the other values in the triangle. Sometimes that's all you can use, but if you can avoid using your rounded answer, that will help your other answers be as close to exact as possible. This means the next thing we need to do is find either angle D or angle F. And it really doesn't matter because we have to find both of them. I'm going to go ahead and find angle D next. I'll just pick that. When I look at my picture, if angle D is the angle I want to solve for, that's that angle at the top. Notice 6 is adjacent and 20 is the hypotenuse. So if we think SOHCAHTOA inverse, that would be the cosine ratio. Cosine angle D equals adjacent over hypotenuse, which in this case would be 6 over 20. So we say cosine D equals 6 over 20. Now this is what we have to do like we did in that last example. To get D by itself, we're going to take the inverse. But instead of tangent, we'll do the inverse for cosine. That's what moves cosine to the right-hand side. So go ahead and give that a try. Type in cosine inverse of 6 over 20 and see what you get. Round your answer to the nearest tenth and be sure to label. You should get 72.5 degrees. And remember, that's an approximation. Your goal, if anything, is to make sure to not use those if possible. And we could do another we could do another SOHCAHTOA rule to help us find angle F. So if we choose angle F as the angle we're solving for, we now have to recognize that adjacent and hypotenuse may not always be true. Well, the hypotenuse will always be 20, so let's figure out what's going on with that 6. So this time, if I want to solve for angle F, now 6 isn't adjacent, it's opposite. And 20 is still the hypotenuse. That means we're going to use the sine ratio. Sine F equals opposite over hypotenuse. And notice that fraction stays the same as it did last time, 6 over 20. But to get capital F by itself, we have to take sine inverse of 6 over 20. If you type that in, you should get approximately 17.5 degrees. And that's the process for solving a right triangle. I didn't give myself a lot of room for this next one, so I hope that you have enough room. Triangle ABC. So we're back to the triangles we've been using kind of in most of the time in this lesson with right angle C. Let's go ahead and draw a right triangle. I'm just going to kind of squeeze mine up here and put your right angle in the corner, and that has to be capital C. That means A and B can be anywhere else on either of those two smaller acute angle locations. Notice capital A is 35 degrees, so I'm going to mark that on the inside. And little c is 14. When this is your given information, the first and easiest thing to do is to calculate angle B, the missing angle in that triangle. We don't need to do SOHCAHTOA inverse. That's supposed to be an angle symbol, not an L. Sorry for the confusion there. We don't have to do SOHCAHTOA inverse for this one because we know 2 of the 3 angles in the triangle. We'll just do the triangle sum rule. I'm going to take 180 minus 90 and minus that 35. That means angle B is going to equal exactly 55 degrees. And we're done with that part, just like that. But we still need to find the length of little a at the bottom and little b on the left. And that's where SOHCAHTOA will come in to help us. If I find little a first, and capital A is given, that would mean little a is opposite, and 14 is the hypotenuse. So I'm going to take sine capital A, which is sine 35, equals opposite over hypotenuse. To get A by itself, we'd simply divide or multiply both sides by 14. Once you get that variable isolated, you can type everything in on the left side all at once. So it's kind of a fast process here. If you type in 14 times sine 35, you should get approximately 8.0 to the nearest tenth. Now, to get that last side length B, I'm now going to change up what's opposite and adjacent. From 35, side length B is now the adjacent side. And then 14 is still the hypotenuse. That means we would apply the cosine ratio. Cosine of angle A, which is 35 degrees, equals adjacent over hypotenuse. And we multiply both sides by 14 again. A pretty consistent process. Type that into your calculator all at once to get approximately 11.5. Anytime you're asked to solve a right triangle, you'll either follow the process on the left or the right, depending on the order that you have your given information. The rest of the lesson is going to be all about application. So I'm not giving you all the specific information. We have to do some generating. Find the measure of the smallest angle in a 3, 4, 5 right triangle. If it doesn't show a degree symbol, those are the side lengths. So let's go ahead and create a triangle, and we'll make it a right triangle. But now I don't know A, B, or C. We don't know what the capital letters are. I'm just going to put my right angle in the corner. Now, if the side lengths are 3, 4, and 5, where would we put those? Because it's going to matter. Recognizing that in a right triangle, the biggest side is always the hypotenuse, the 5 has to go there. And that means the 3 and the 4 can go in either of the other 2 sides that form the right angle. I'll put the 3 at the top and the 4 at the bottom. Now, if we want the measure of the smallest angle, by rule, the smallest angle in a triangle is always across the shortest side. So if the shortest side is 3, then the smallest angle is this angle at the bottom, and we'll call that theta. Since we know all 3 side lengths, we can pick any trig definition, sine, cosine, or tangent. It truly doesn't matter. I'll go ahead and pick cosine, just for something, I don't know, just to gotta pick one. Cosine by definition is adjacent over hypotenuse. The adjacent side is 4, the hypotenuse has to be 5. That simply means cosine theta is equal to 4/5. To get theta by itself, let's take cosine inverse. Type that into your calculator, and you should get the smallest angle in that triangle to have a value of 36.9 degrees. We're going to take a break for a moment and then dive into the rest of these application problems.